This is GCSE Further Mechanics. We are in Unit 2. We are resolving forces within Newton's laws. And I've actually added a wee extra example in here just as an extra explanation. So it's down here. It's going to be this one here. That's 30, that's 25, that's 15, and that's 5G acting down vertically. Now you might want to pause the video then and copy this one down. This is kind of a more, I guess, realistic example with the 5G because this causes an awful lot more hassle. So we need to try and suss out what we're going to do here. So we're going to resolve along the plane. But that's 25, that's 15, that's easy, that's 5G. It's just going to be a wee bit messy. So we just need to see what angle it's going at. You can do this a couple of different ways. You could drop this down here and realize that this is a wee right angle triangle. And if that's a right angle, if that's 27, that's going to be 63. And that there, then it's going to be 27 as well. And that tends to be how I work it out. It's worth taking a wee second to see if you can suss out why that is 27, but that helps us if we can get that. Okay, so resolving this way, I'm going to be taking, let's see, we'll go downwards to be positive in this case. Only because the one I'm copying has that. But we have that, so it's going to be 15. And then plus, can you see that the 5G is going to be acting this way? So it's 5G, and we're not going across that 27 when we're resolving this direction here. So it's going to be sine, so it's 5G sine 27. Cos across was something I said a few videos ago, and another one is sine slope. If you're resolving the weight going down the slope, it tends to be sine of this angle here. And then we have minus 25. So this takes a wee bit of thought. You maybe want to go back over that and check, and hopefully it makes sense where I've got that from. And if we work that out, it gives us 37.82 newtons, and that's acting that direction here. The other way we're going to go then is that we're going to resolve this way here. So what do we have going this way? We have a 30 going this way, and then take away 5G, and I am going to cross that 27, so it would be cos 27. Putting that into your calculator, 30 take away 5G. Remember, G for us is 10, so that would be then 44.61 newtons. I've changed my 1, 2, 3, 4 random forces into 2 orthogonal ones. So what do I have? I have 37.82 going down the slope, and then I have 44.61 going up. So let's draw this one on. I have that one, which is the 37.82, and I have this one, which is a 44.61. That's my right angle. It was going that way. My resultant force goes from the start of the first to the end of the second, so it's going to be there. And the angle I'm looking for then, it's going to be like that, above the slope. Again, Pythagoras will sort this out for us. R squared equals 37.82 squared plus 44.61 squared. R squared is 3420.40, and R then comes out to be 58.48 newtons. Not sure why I've written it equals there. I'll have that. Working out my angle. Tan theta is O over A. Tan theta is 44.61 over 37.82. Theta is tan to the minus 1, 44.61 all over 37.82. So theta in this case then is 49.7 degrees. Final wee statement then would be resultant is 58.5 newtons downhill 49.7 degrees above the plane. So the reason we did this one is because of this awkward looking force here, and this appears an awful lot, so we want to try and get used to it. Bit of advice is if you're resolving this one down the slope, it's sine, and then going the other way, it's going to be cos.